So for this example, our steps are still the same. I need to make sure that my equation is equal to 0 and then write it in factored form. So looking at this, my equation is equal to 0, which is great. I can skip that step and immediately start factoring it. However, if you look closely, this is not written in standard form because my b value actually comes before my a value, while c is still in the same place. So for this, if it helps you, you can rewrite this into standard form as negative 3x squared minus 2x plus 5. And then from here, you can begin doing your x box. So a times c would go at the top, negative 3 times 5, so negative 15. And then your b value at the bottom, negative 2. So two numbers that multiply to negative 15 but add to negative 2 would be negative 5 and positive 3. From here, I can rewrite, replace, rewrite. So I'm rewriting my a value, negative 3x squared. I'm replacing negative 2x with negative 5x and positive 3x. And then I'm rewriting my c value, positive 5. Next, I want to group my first two terms and my last two terms. And I want to look at what I can factor out. So for this first example, I have negative 3x squared and negative 5x. And so what I can do is I can factor out a negative 1x. And for the last example, last set of parentheses, I can't factor in an x because 5 does not have an x. However, the only number I can divide 3 and 5 by is 1. And so that's what I can factor out. So if I do that, if I factor out negative x from the first set of parentheses, that leaves me with negative x times 3x plus 5. And if I factor out a positive 1 from my second set of parentheses, that also just leaves me with 3x plus 5. And again, at this point, you should have the exact same thing in your parentheses, which I do. So next, I can write it as my two inside terms, 3x plus 5, and then negative x plus 1. And this is still equal to 0. So this now is my factored form. To find the solutions, I'm going to take each one, set it equal to 0, and solve for x. So this would be 3x plus 5 equals 0, and negative x plus 1 equals 0. So in this first example, I would subtract 5 from both sides. So I have 3x equals negative 5, divide by 3. So x equals negative 5/3. And you can leave it like that. You can leave it as an improper fraction. Over in this next example, I would subtract 1 from both sides. So I have negative x equals negative 1. But I never want a negative x as my solution, so I can either multiply or divide both sides by negative 1 to cancel out that negative. So this would be x equals positive 1. So those are my two solutions for this quadratic equation. Let's do one more. Okay, so as you can immediately see, this one is not equal to 0. So what I need to do is I need to subtract 2p from both sides. So that leaves me with 3p squared minus 2p minus 5 equals 0. And I put the minus 2p where it is because I wanted to automatically put it in standard form. Okay. Now that it's equal to 0, I can do my x box, where I have 3 times negative 5 at the top, so negative 15, and negative 2 at the bottom. This should look a little familiar. So these two factors are negative 5 and positive 3. So rewrite your a term, replace b with negative 5p plus 3p minus 5 equals 0. Group your first two terms and your last two terms together. For this first one, I can factor out just p, and then here I can only factor out 1. So if I do that, I'm left with 3p minus 5, and if I factor out 1, I'm again left with 3p minus 5. So if I write it in factored form, it's my inside terms and my outside terms. So my outside terms is p plus 1, and the order doesn't matter. 3p minus 5 equals 0. So this is factored form. Now to solve it, set each one equal to 0 and solve for your variable. So p plus 1 equals 0, 3p minus 5 equals 0. So here's one solution. And then over here, 3p equals 5, divide by 3, so p equals 5/3. Okay, so again, make sure that your equation is set equal to 0. If it's not written in standard form, you definitely want to write it in standard form. It'll make it easier for you to factor it. So set it equal to 0, write your equation in factored form, and then solve for your x-intercepts, which is solving for your variables, which will give you the solutions to your equation.